Addition reactions. Today our topic is nucleophilic addition. In the last class, we have discussed nucleophilic addition to carbon double bond carbon. If the it is rare, but in case if electron withdrawing group is present in conjugation with double bond, then it will be possible. The very famous example of nucleophilic addition to carbon double bond carbon is Michael reaction. Now we are going to discuss nucleophilic addition to carbonyl. In the previous lecture, we have discussed alkene give electrophilic addition because the pi electron of alkene act as nucleophile, and this double bond carbonyl give nucleophilic addition because this is a polar bond. Oxygen has high electronegativity, so carbon is electrophilic center for the attack of nucleophile. So now we are going to discuss nucleophilic addition to carbonyl, structure and reactivity of carbonyl group, addition of hydrogen cyanide to carbonyl, addition of alcohol to carbonyl, mechanism of hemiacetal formation, acetal formation. So these topics will be discussed in this lecture. This is the lecture 8. Now this is lecture 8, addition reactions, nucleophilic addition to carbonyl. Nucleophilic addition to carbonyl. The first we will discuss is structure and reactivity of carbonyl group. This is aldehyde and this is ketone. What is the difference? This hydrogen. Carbon is attached with alkyl and hydrogen. Carbon is attached with two alkyl groups. They may be different, they may be same. This alkyl group has electron donating effect plus inductive effect. So this carbon is electrophilic in nature due to presence of this high electronegative oxygen. Electron donating effect due to electron donating effect or plus inductive effect of alkyl, the electrophilic character of this carbon is decreased. But in case of ketone, two electron donating groups, two plus inductive effect of this alkyl and plus inductive effect of this is alkyl. So electrophilicity of this carbon, electrophilic character of this carbon will decrease more and more as compared to aldehyde, because here only one alkyl group is decreasing the electrophilic character of this carbon. In case of ketone, two alkyl groups are decreasing the electrophilic character of this carbon. So aldehyde is more reactive towards nucleophilic addition because nucleophile attack on this carbon. If it will be more electrophilic, the reactivity will be more. So aldehydes are more reactive as compared to ketone towards nucleophilic addition reaction. Aldehydes are more reactive. In another thing, this carbonyl, aldehyde or ketone, before addition, this is the simple reaction, nucleophilic addition reaction. Before reaction or before addition, before nucleophilic addition, this carbon is sp2 hybridized. Sp2 hybridized means it is planar. The structure is planar. Two planes are available for attack. For the nucleophile, nucleophile can attack on the above top face, and nucleophile can attack from the bottom face. So two faces. The one face is called re phase, and the second phase is called psi phase. Re and psi phase. Two faces or two planes or two faces are available for attack above and below. So the stereo, this carbon is not the chiral carbon, but this is the prochiral. This center is not the chiral center but prochiral, because after reaction it will be chiral. So this type of center are called prochiral centers. After reaction, this is the nucleophilic addition. Nucleophile is added, and now the carbon is sp3 hybridized. Sp3 hybridized. If the carbon has four different groups, it means it is chiral, and nucleophilic addition will give two uh, stereoisomers R and S because two-side attack. Rephase attack give R stereoisomer and psi phase attack give S stereoisomer absolute configuration as the racemic mixture will be obtained. So this is the stereochemistry of nucleophilic addition. Now we are going to describe simple addition reaction. Addition of hydrogen cyanide. This is hydrogen cyanide, partially positive and partially negative. This is nucleophilic in nature. It can attack on this electrophilic carbon. In result, the hydrogen is added with this oxygen. This is called cyanohydrin. This carbon, this is pro-chiral center and this is the chiral center, four different groups. So in result, R and S stereoisomers will be obtained or racemic mixture will be obtained. This is the reaction of hydrocyanide with aldehyde, and this is the reaction with ketone. Same reaction, R and S absolute configuration stereoisomers will be obtained. The second reaction is addition of alcohol. Addition of alcohol, hemiacetal and acetal formation. The, the alcohol will be added, then the product which is obtained is called hemiacetal or acetal. So this is the reaction. Alcohol can react with aldehyde or ketone. This lone pair of alcohol can attack on this carbon and shifting of pi electron towards oxygen. In result, this alcohol is added and shifting by reversible process. Hydrogen is shifted, H plus is shifted towards oxygen. Then you will obtain hemiacetal. Hemiacetal. When OR will be attached with this carbon and hydrogen will be attached with this oxygen. So this is hemiacetal. This is unstable. It can further react with another molecule of alcohol and it is converted into acetal. So acetal is highly stable as compared to hemiacetal. Hemiacetal is the intermediate of acetal. Cyclic hemiacetals are much more stable and isolated. 5 to 6 membered ring cyclic hemiacetals are stable. So cyclic structures ज़्यादा stable होते हैं as compared to acyclic structures. For example, ये एक OH है in the intramolecular reaction, यानी इसी में OH लगा हुआ है, same aldehyde group is also present. तो ये ऑक्सीजन अटैक है और ये यहाँ पे ऑक्सीजन आ जाता है, यहाँ पूरा एक ग्रुप आ गया. दिस इज साइक्लिक स्ट्रक्चर, 5 membered ring will be obtained. This is the hemiacetal, cyclic hemiacetal. This is more stable as compared to acyclic hemiacetal. This is the carbon, the OH is attached, this ऑक्सीजन है, OH अटैच, और दूसरा ये पूरा जो अल्काइल ग्रुप है, OR ग्रुप जो है, ये पूरा यहाँ पे अटैच हो गया. दिस इज हेमियासिटल. Glucose is glucose is in hemiacetal form. This is the glucose. It is in hemiacetal form. Why? Because this carbon, this is the carbonyl carbon. The OH is attached and OR is attached. एक OH लगा हुआ है, this is carbonyl carbon aldehyde. यहाँ पे alkyl group है, एक हाइड्रोजन भी लगा हुआ है, और जो हेमिएसिटल फॉर्मेशन है, एक तो ये O अल्काइल लग गया और दूसरा OH. तो हेमिएसिटल में क्या होता है, एक OR होता है और एक OH. RH तो पहले से लगे हुए, अल्कोक्सी ग्रुप और हाइड्रोक्सी ग्रुप. यहाँ भी ये कार्बन है, एल्डिहाइडिक कार्बन, यहाँ अल्कोक्सी ग्रुप है और ये हाइड्रोक्सिल ग्रुप है. दिस इज द हेमिएसिटल फॉर्म ऑफ ग्लूकोज. सिमिलरली कीटोन फॉर्म हेमिएसिटल. कीटोन भी इसी तरह से हेमिएसिटल बनाता है, लेकिन वो भी अनस्टेबल होते हैं, जैसे कि एल्डिहाइड के ऐसे हेमिएसिटल अनस्टेबल होते हैं. लेकिन जो साइक्लिक हेमिएसिटल हैं, चाहे वो एल्डिहाइड के हों या कीटोन के हों, दे आर मोर स्टेबल एज कंपेयर टू एसाइक्लिक हेमिएसिटल. For example, this is alcohol react with the ketone in the similar manner we will obtain hemiacetal of ketone. This is also unstable. This is the mechanism of hemiacetal formation. Acid catalyze hemiacetal formation. The hemiacetal will be obtained by both acid catalyzed reaction as well as base catalyzed reaction. This is the mechanism of acid catalyzed uh, uh, reaction. This ketone or aldehyde react with alcohol. This alcohol will be first acidify because in the acidic medium, alcohol is acidified. It will take H plus. This is acidic form of alcohol. This oxygen will take H plus. This is the oxoniamine oxygen which has three bonds and positive charge. It is oxoniamine. Now this lone pair of oxygen attack on this carbon. That in result we will obtain this product OH, and this is ROH. Then RH will be removed by alcohol. Then you will obtain hemiacetal. This is the removal of H plus. First, the H plus is added, and at the end, H plus will be removed. So H plus, this oxygen will take H plus from alcohol. This is oxoniamine, then alcohol attack on this electrophilic carbon, then OH and ROH by reversible process. H plus will be removed, then you will obtain hemiacetal, OR and OH. This is the base catalyzed hemiacetal formation. Base catalyze hemiacetal formation. In presence of base abstract H plus of alcohol, then you will obtain alkoxide ion. This in acidic medium, alcohol is in the form and in the basic medium, alcohol is in the form of alkoxide. This alkoxide has a nucleophile attack on this electrophilic carbon, shifting of electron towards oxygen. This OR is attached with this carbon, and this oxygen, which has negative charge, it will take H plus from alcohol. Then this is OH and this is OR, or RO will be removed, alkoxide ion. The alkoxide ion is added, then it will be removed at the end. This is hemiacetal formation. This is hemiacetal in base catalyzed reaction. The acetal formation, the third reaction, first addition of hydrogen cyanide, second addition of alcohol, in result hemiacetal formation, third acetal formation. This is the two-step reaction. First hemiacetal will be obtained, then acetal formation. We have already discussed this hemiacetal formation by adding uh, one molecule of alcohol. The second molecule will be added, then we will obtain acetal. What is the difference between hemiacetal and acetal? All the groups are retained, but OH is converted into OR dash. This is the second alcohol molecule is added. OH is converted into OR dash. This OR dash first in the first step, the OR dash is added. In the second step, again OR dash is added instead of OH. So this is the hemiacetal is further converted into acetal, and acetals are more stable as compared to hemiacetal. This is the molecule of sucrose. How many acetals are here? How many acetals are here? There are two acetals. This one and this is second. First, this one, alkoxy group, this one, and alkoxy group, this one. This is alkyl, and this is also alkyl. So this is alkoxy, and this is alkoxy. First acetal, second acetal, this is alkoxy group OR, and second alkoxy group OR. So two acetal groups are here in the molecule of sucrose. So the conclusion is that acetals one molecule of alcohol is added to the carbonyl compound, then you will obtain hemiacetone, and the second molecule is added, then you will obtain acetone. Acetone are always stable as compared to hemiacetone. Although cyclic hemiacetals are more stable as compared to acyclic hemiacetal, and cyclic acetals definitely they are highly stable as compared to uh, acyclic acetal. So we can give the number of examples of acetals. The acetals are used as a protecting group in the reaction of organic chemistry. The carbonyl is converted into acetal. Then, after the reaction, the acetal will be removed, and then you will retain carbonyl group. So this is the end of this lecture. Any question, if you can ask? जी कोई सवाल पूछना चाहते हैं यहाँ पे? जी नहीं, चलो बस यहीं ख़त्म करते हैं। ठीक है, अपना ख्याल रखिएगा। अल्लाह हाफिज़।